Hello viewers, in today's session we are going to discuss this important definite integral involving a mod function, and here we have to evaluate the integral that is from 0 to 1 by 4, and here the integrand is mod of sine 2 pi x, right? So let us call this integral as I. So here we'll first make use of the method of substitution, and then will apply some properties of mod function and sign convention of trigonometric functions in four quadrants. So here let us substitute theta is equal to 2 pi x, right? So here we introduce this variable theta, and we'll take theta is equal to 2 pi x. Let us differentiate theta with respect to x. D theta over dx is equal to d by dx of 2 pi x, and we can write 2 pi, and here the derivative of x with respect to x is 1, so this is 2 pi. So d theta over 2 pi is equal to dx, right? And here x varies from 0 to 1 by 4, so let us change the limits accordingly. When x is equal to 0, then the value of theta can be obtained from this expression, that is 2 pi times 0 is equal to 0. And when x is equal to 1 over 4, then theta is equal to 2 pi times 1 over 4, and here we have pi over 2. So when x changes from 0 to 1 by 4, theta varies from 0 to pi by 2, right? So now this integral I can take the form in terms of theta, that is theta varies from 0 to pi by 2, and here we have mod of sine theta. For 2 pi x we write theta, and for dx we can write d theta over 2 pi. So now taking 1 over 2 pi outside the integral, we have 0 to pi by 2, and here we have mod of sine theta and d theta. So let us now apply the definition of mod function to this integrand, that is mod of sine theta. Now see, we know that mod of p is defined as positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is equal to negative p whenever p is less than 0, right? And here if we look at the four quadrants, then here we have theta 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have here a 2 pi. So this is the first quadrant, this is second, this is third, and this is fourth, right? Now here the value of theta, it goes from 0 to pi by 2, right? So it implies that we have to restrict ourselves to the first quadrant only. And from trigonometry we know that all the six trigonometric functions are positive in the first quadrant, right? So here sine theta is greater than 0 when theta belongs to the first quadrant, right? And in other words, we can say that when theta belongs to this interval, that is 0 to pi by 2, then sine theta is always going to be positive, right? So if we take sine theta as p, then mod of p, that is mod of sine theta, is equal to positive sine theta when sine theta is greater than 0, and theta belongs to this interval, that is 0 to pi by 2, right? So now we have 1 over 2 pi, and we have 0 to pi by 2, and mod of sine theta can be replaced by positive sine theta here, and the integral of sine theta is the negative cos theta, and limits are from 0 to pi by 2, right? So now we can write this negative sign outside here. We have minus 1 over 2 pi, then we have cosine theta, and limits are from 0 to pi by 2. Now we can substitute the limits and we'll take the difference. So we have cos pi by 2 minus cos of 0, right? So now the value of this integral is equal to minus 1 over 2 pi, and cosine pi by 2 is 0 and cosine 0 is 1. So we have minus 1 over 2 pi times minus 1. So minus times minus, this is positive. So we have plus 1 over 2 pi, right? So the value of this integral is equal to 1 over 2 pi. Hello viewers, in today's session we are going to discuss another important problem from integrals. So here we are given two functions. F1 x is equal to mod of x minus 1 and f2 x is equal to greatest integer of x, and we have to find the value of this integral, that is from minus 1 to 0 f1x multiplied with the square of f2 of x, right? So here we have the mod function, that is f1x is the absolute value function, that is mod of x minus 1, and f2x is the greatest integer of x. So now to evaluate this integral, we can make use of the definition of mod function and greatest integer function. So the definition of mod function and definition of greatest integer function can easily lead us to the value of this integral, right? Now see, a mod function is defined like this: mod of p is equal to positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So let us apply this definition to this function. So we have mod of x minus 1, so this is a positive x minus 1 whenever x minus 1 is greater than 0. So here p can be taken as x minus 1. So here x minus 1 is greater than 0, then mod of x minus 1 is positive x minus 1. So from this inequality we have x greater than 1, right? And mod of x minus 1 is equal to 0 whenever x minus 1 is equal to 0, that is x is equal to 1. And this is mod x minus 1 is equal to negative x minus 1 whenever x minus 1 is less than 0, and this implies x is less than 1, right? So in this problem the important thing is to make use of this part of the definition, right? That is mod of p is equal to negative p when p is less than 0. So here we'll make use of this part of the definition, right? So here x varies from minus 1 to 0, right? So we have x belonging to the interval that is minus 1 to 0. So here we have 0 and here we have minus 1. So let us take this integral as I. So when we vary x from minus 1 to 0, then all the values of x are obviously less than 1, because all the x are falling between minus 1 and 0, right? So here x is less than 1, so all the values of x falling in this interval are less than 1. So here mod of x minus 1 is it can be written as negative of x minus 1 when x is less than 1, because here the limits of integration are from minus 1 to 0, right? So now this integral I can be written as minus 1 to 0, and f1x is mod of x minus 1, and here f2 of x is the greatest integer of x square, right? Okay, so now we can replace mod of x minus 1 as negative x plus 1, right? So here we have minus 1 to 0, and here we have minus x plus 1. And now let us see this function, that is greatest integer of x. Now here we have x greater than or equal to minus 1 but less than 0. So whenever x is greater than or equal to minus 1 but less than 0, then by definition of greatest integer function, the value of greatest integer of x is equal to minus 1, right? So here we'll replace greatest integer of x by minus 1, so we have minus 1 square and dx. So here we have used the definition of greatest integer function. When x is greater than or equal to minus 1 but less than 0, then the greatest integer of x is equal to minus 1. Similarly, when x is greater than or equal to minus 2 but less than minus 1, then the greatest integer of x is equal to minus 2. And similarly, when x is greater than or equal to say 2 but less than 3, then the greatest integer of x is equal to 2, right? So here we have used the definition of greatest integer function. So x greater than or equal to minus 1 but less than 0, the greatest integer of x is equal to minus 1, because here the limits of integration vary from minus 1 to 0. So now we can simplify. We have minus 1 to 0. Minus 1 square is positive 1, so we have simply minus x plus 1 and dx. Now the integral of minus x plus 1 is simply minus x square over 2, and the integral dx is here simply x, and limits are from minus 1 to 0. So let us substitute the limits and we'll take the difference. So when x is equal to 0, both these terms are 0 here, and when we have x is equal to minus 1, then we have minus 1 square is positive, so we have minus 1 over 2, and then here we have minus 1, right? So this is 0, and here we have minus 1 over 2 minus 1 is minus 3 over 2. So this is a minus minus plus, so we have 3 over 2. So the value of this integral is equal to 3 divided by 2, that is simply 1.5.